Welcome to this Python Basics course about tuples and lists. You've learned about a bunch of fundamental data types at this point. You've learned about strings, integers, and floating point numbers, for example. But what if you want to describe a collection of elements? How do you combine several fundamental data types into something that's more complex? Or from another perspective, what if you have a bunch of lonely elements? Don't you just want to hug them all together? Well, there are certain data structures in Python that can model such a collection of data. For example, a list of numbers. You can have student names that are enrolled in a class, or a row in a spreadsheet, or similarly, a record in a database. Or, of course, all your favorite animal emojis. Woof. In this course, you'll learn how you can work with tuples and lists, when you want to use which of these two collections, as well as what mutability is and why it's important to think about it. Currently, you are in the overview of this course. You'll then move on to tuples, then lists, and then we'll wrap up the course with a summary. To expand on this table of contents a bit, on this slide, you can see all the many topics that you're going to cover. First about tuples and then about lists. Now, there's a little bit of background, which is that I'll be using idle in this course. If you're following along with the Python Basics series, then you're already familiar with this tool. If not, then here on this slide, you can see a couple of additional resources that you can use to study up on idle if you want to. But you don't need to know anything about idle. You can work through this course with any code editor or REPL session that you want to. And that's it for the overview. So next, let's get started learning about tuples. Let's get started talking about tuples, or immutable sequences. And I want to start off this part of the course by helping you to find a way to think of tuples as rows. Let's start off by how do you even pronounce this word? There's actually two valid pronunciations of the word tuple. The first one is the one I just said, tuple. So you would pronounce it like in the word quadruple. And another one is tuple, like in the word quintuple. Both of these pronunciations are fine, and both are used throughout the Python community. So you can pick either, you can mix and match, or you can just settle on one of those. It seems like eventually I settled on calling them tuples, even though I remember also talking about them as tuples sometime in the past. And I may end up throwing in a tuple here or there during this course just to make sure that everyone's happy or everyone's unhappy. I don't know. Both of these pronunciations are fine and refer to the same thing in Python. Now, what is that thing in Python? What is a tuple? A tuple is a finite, ordered, immutable sequence of values. That's a mouthful. It gets worse. Python borrows the name and the notation from mathematics, which means, per definition, each element is separated by a comma inside a tuple, and all the elements are surrounded by a single pair of parentheses. This is a tuple that contains three elements. In Python, that would be three integers, 1, 2, and 3. Okay, so that's maybe the definition, but it's not super helpful to really understand what a tuple is. So I want to give you some help in remembering an approximation of how you can think about a tuple in Python. It's very helpful to think about database records in that context, or rows in a spreadsheet. You may have worked with some sort of a spreadsheet application before. You have some sort of idea of what a spreadsheet looks like, and that it consists of multiple columns and multiple rows. Here in this example, you'd see an employees sheet that has 3 columns, employee ID, name, and role. And then it has 3 rows that each contain data. You could think of a Python tuple as one row in this spreadsheet or one record in the database, right? So the first row here, you could represent it as a Python tuple as shown at the bottom of this slide. So here you would surround the information that is given in the row with parentheses and separate each of the values in each column with a comma. So the first one is the employee ID, which here has the value 1. So you would put in an integer as 1, separated with a comma from the next value. The next one is the name, in this case, Adisa, and that would be a string in Python. So you would write out the string Adisa, put a comma again, and then you're in the third column. That's the role, and in this case, she's a software engineer. So you would put this words software engineer also as a string in Python as the third item in the tuple. So while this isn't a perfect explanation of what a tuple is, it's a pretty good approximation if you think of a tuple as a read-only database record. So one of these rows, but read-only. Why is that? A read-only database record is a finite sequence of values. It ends at some point. It has a fixed structure. You usually don't change these columns around very much. It has fixed values, that is, if it's read-only. And it contains a variety of data types. In the one you saw before, you saw some text and you saw some numbers. And it also usually contains related data. So each row, the data that is in the different fields is related to each other. And if you keep that in mind, that a tuple is kind of like a read-only database record, you have a good chance of using them in the way that they're intended in Python. Again, if you walk away from this course and in the evening you remember that you've heard something about tuples, but you're like, what was this thing again? Tuple, tuple? Then I want you just to think, all right, it's a read-only database record. And if that approximation gives you some sort of an idea, then I think you've got a better grasp on how to think about tuples in Python. That is what a tuple is, and you'll explore them in much more detail in the following lessons. In the next one, you're going to learn how you can create a tuple in Python. In this lesson, you'll learn how you can create a tuple in Python. You'll learn about two ways, tuple literals, and you'll learn about the built-in tuple function. Before we go to tuple literals, though, here's a quick throwback to string literals. You can create strings by just surrounding characters with quotes, either single quotes at the beginning and the end, or double quotes at the beginning and the end. And both of these create a string literal. Now, I'm mentioning these because tuples and strings have quite a lot of things in common, as you'll see in the upcoming lessons. A string literal is surrounded by quotes, and a tuple literal are comma-separated values that are surrounded by parentheses. This is a tuple literal that starts with a parentheses and ends with a parentheses, and in between it has multiple values that are separated by commas. These values can be of any type. They don't all have to be integers, like in this first example, but they can be a mix of strings and integers and floating point numbers, really any Python data type that you can think of. Here is another tuple that you've seen before. This would be maybe one employee and the record in the database where you can see the first value is an integer, and then you have two strings following that, and it's all surrounded by a parentheses, and each of the elements are separated by commas. This is how you create a tuple literal. Let's go ahead and try that out in idle. All I did was start with a parentheses, then I can type in as many values as I want to. And when I press enter, you can see that here you get a tuple back out. And let's double check that it's really a tuple. So I'll assign it to a variable that could be maybe winning positions in a race. 1, 2, 3. Only the first 3 get a medal. And now we can look at winning positions. You can see that that's this tuple, 1, 2, 3. And to prove that it's actually a tuple, I'm going to pass it as an argument to the type function. And then Python tells me that this is indeed of the class tuple. The second one that you've seen in the slides would be maybe an employee of your company. And that's the first employee. Her name's Adisa. And she's a software developer. You end the tuple by closing the parentheses again. And here you go. You've got your employee tuple. And again, let's double check that it is indeed a tuple, even though it contains all sorts of different data types here. Again, this is a tuple. So this is a way that you can create a tuple literal. You use the parentheses and you separate it by commas. I'll tell you a little secret. It's not so much of a secret, but the parentheses are actually optional. What makes a tuple are the comma-separated values. So I could create the same tuple also without the parentheses at the beginning and the end. Let's just do an example one. 1, 2, 3. If I just type it in like that, I also get a tuple as a result. So assign it again to numbers 1, 2, 3. And the type of numbers is going to be a tuple. And also, you see, if I just type in numbers, then Python prints the output with the parentheses around it, because this is how tuples are represented. But when you define a tuple literal, you don't need to put the parentheses there. However, I would suggest to always do it because it makes it more clear what you're actually creating here. So this is how you create a tuple literal. Another way of creating a tuple is by using the built-in tuple function. With this, you can pass in another sequence type and create a tuple from that. Now, what's another sequence type that you've already encountered? Those are the strings that I mentioned before. So you can pass in a string to the tuple function and Python will create a tuple for you. Let's try that out in idle as well. Let's assign it to something, word equals tuple, and then I pass in a string that says Python. Then you will see that what I get as a result is a tuple. A tuple that consists of all the elements of the string sequence. So remember that strings are sequences of characters. And what the tuple function does is it splits it up into the characters that the string consists of and assigns them each as an element in the tuple. So this is the second way that you can create a tuple from another sequence type by using the tuple function. Keep in mind that this needs to be a sequence type. So if you try to call tuple and pass it, for example, an integer, then you'll get an error because the integer object is not iterable. So the argument that you pass to the tuple function needs to be iterable or a collection. All right, so this is how you can define a tuple. And next up, I'll continue to compare tuples and strings a bit more because you'll see they have quite a bit in common. And if you have somewhat of an understanding of strings, it'll help you to better understand tuples as well. Previously, I've mentioned that tuples and strings have things in common. Now, in this lesson, we'll go a little bit deeper into this comparison between tuples and strings. I'll start off by showing you some similarities between tuples and strings. Let's start with an overview. Tuples have a length, tuples support indexing and slicing, tuples are immutable, and tuples are iterable. All of these things they have in common with strings. Start off by looking at the length of a tuple. Just like with a string, you can call the len function and pass it a tuple, and as a result, you'll get how many elements are in the tuple. Let's try that out in idle. So you've seen a numbers tuple that just points to 1, 2, 3. And then we can pass it to the len function, and you can see that as an output, you get the number 3. Now, let's compare it to a string, right? We worked with the word Python before, and the word Python has also a length of 6. Now you could even turn the word Python into a tuple because a tuple can consist of any sort of data type. So it doesn't have to be integers, it could be strings. So what we did before was to split up the word Python into its characters, each a separate string, and make them the elements of a tuple. Let's do that again. I'll call it the word tuple and just pass our word to the tuple function. And now we have word tuple consisting of the separate characters of the word Python. And this also has a length, right? So this should be the same length as the word. And here you go. It consists of 6 characters, just like the string Python consists of 6 characters. Further, each element in a tuple has a numbered position called an index. That's also the same as it is with strings. So you can access individual elements through their index. And you do that by placing the index number inside of a pair of square brackets right after the tuple. You've probably done this with strings before, but here's an example. Again, with the numbers list. Here we've defined a tuple called numbers, which consists of 3 elements, 1, 2, and 3. And then in the next line, you're accessing the element at index position 1, and that is the number 2. As an output, you're going to get the number 2. And note that the index count starts with 0, like in most programming languages. So 1 is at the index 0, 2 is at index 1, and 3 is at index 2, which is why when you access the element at index 1, you get back out the number 2. So just a quick recap of indexes or indices. You can use either of the plurals. It's just like tuple and tuple, huh? Here's a string and the relevant indexes for the characters in the string. The letter P would be at index 0, the letter Y would be at index 1, etc., up to the N, the last letter of the word Python, which is at index 5. The same goes for tuple indexing. So if you think of an expanded numbers list that has the first 3 numbers under 10 and then the last 3 numbers under 10, so it consists of 1, 2, 3, 7, 8, and 9, then you'd find the number 1 at index 0, the number 2 at index 1, etc. And at index 5, you'd find the number 9 in this case. Also, Python supports negative indexing, which means that you can go backwards. This is also the same as with strings. So you can access the integer 9 in this example tuple also by using -1 as the index number in square brackets and all the way backwards so that you could access the first element in this specific tuple by passing -6 as the negative index. Now, maybe this sounds a little abstract, so let's try it out again in idle. I'll work with word and word tuple. So if you remember string indexing, I'll access the P, the first element, by passing in 0. I can see that I get out the P. And with word tuple, I can do the exact same thing. Word tuple, open up the square brackets, put in the 0, close the square brackets, and again, I get the P. Now let's take a look at something in between. Maybe we want to get out the T of Python. So in the word tuple, I can pass in the index position that would be P is at 0, Y is at 1, and T is at 2. So if I pass in 2 as the index number, I'll get out the T. And again, this is the same if you do it with a string. And finally, also the negative indexing. So if you want to get the last element here, you could pass in the index number 5, but you could also go backwards and say word underscore tuple, open up the square brackets, and then pass in -1. This is going to give you the last element in the tuple. And in this case, that's an N. Now you may think, okay, so that's exactly the same as with the string. What's the point? Well, the point is tuples can't only just contain characters. They can, for example, also contain numbers. So we have this numbers tuple, right? And you can do the same thing that you did with the string elements in a tuple also with numbers. So I can access the last element of the numbers tuple by passing in -1, and this will give me the number 3 as an output. So tuples and strings both support indexing. Tuples also support slicing. So you can extract portions of a tuple just like you can do with a string by inserting a colon between 2 index numbers. For example, here with square brackets 0:2, closing square brackets, you would slice out the first 2 items of a tuple. Or here, let's look at another numbers list. For example, the odd numbers under 10 would be a tuple that consists of 1, 3, 5, 7, and 9. And if you were to slice out just 5 and 7, you could use the notation square bracket 2:4. Let's try that out in idle. So here I'll define the odd numbers list. And now let's do some slicing on it. Odd numbers starting from 2 up to, but not including 4, is going to give me 5 and 7. The index always starts at the lower index and includes that one, and then goes up to, but doesn't include the ending index that you put on the other side of the column. So we start at 0, 1, 2. We start here at the number 5. And then this is index 3, is number 7 that's included in the slice. And 9 would be at index 4. And this is where it stops, and it doesn't include the stopping index anymore. So you get 5 and 7 as the slice from this odd numbers list. You can do the same with a string as well. So word is our Python string, and here you can slice out. Let's see what we get if we do 2 and 4. Here you get a T and H, and it works in the same way. To recap, the slice XY starts from the element at index X, and the slice goes up to but does not include the element at index Y. Another thing that they have in common with strings is that tuples are immutable, which means that you can't change the value of an element in a tuple after creating it, just like you can't change a single character in a string once you've created the string. So if you tried to do an item assignment, for example, here we have the numbers tuple and you're attempting to replace the first element with the integer 2, then you get an error because this just doesn't work. Let's try it out live. We still have the numbers tuple here available, so I'll try to change the final element, -1, and I will try to assign it to the number 100. Just as expected, I get the type error that the tuple object does not support item assignment. Again, let's compare it to the string. You'll get the same. So if I wanted to change the first letter of Python to make it say maybe Tython, Python protects itself from something like that. No, it's just the same reason as with the tuple is that strings are immutable, so the string object does not support item assignment. And finally, another similarity between tuples and strings is that tuples are iterable, which means you can loop over them. Let's try that out. So I can keep working with the numbers tuple here, and I can say for each number in numbers, print the number. And you can see that it's iterable and Python can access each element of the tuple separately and then prints it out. First 1, then 2, and then 3. Same with a string. For character in Word, I can print out the character. And then Python prints out each separate character of the string Python. And there's another thing where tuples and strings are similar, which is that they're iterable, just like any collection in Python. And this concludes our little excursion about the similarities between tuples and strings. In our next lesson, we're going to look at tuple unpacking, and I'll show you what you can do with that.